Good morning, children. Let us continue the mathematics lesson, polynomials. Okay, so last class I had given the definition of polynomials, and I had recalled some of the concepts of algebraic expression, that is classification of algebraic expression. Okay, uh, based on the terms, that is monomial, binomial, trinomial, polynomial. Those concepts and all we have recalled on the last class, right? So in this class, let us continue the lesson. So last class I had given the classification. Now I had explained what is polynomial also. Polynomials, it is a special type of algebraic expression. It is also an algebraic expression, but it is having some particular condition. What is that condition? So in that algebraic expression, the variable power must be a whole number. It should not be a negative number, or it should not be a fraction. It should be a whole number. Okay, so that I had explained in the last class, right? Now we have polynomials in one variable. Okay, we have polynomials in one variable. Let us learn what is polynomials in one variable. Suppose I'll write a polynomial like this. Okay, a cubic plus 2ab plus 3b. So this is a polynomial, right? Okay, of course it is having three terms. Definitely it is a algebraic expression. An algebraic expression having one or more terms is called as a polynomial. So definitely it is a polynomial. Observe the variables. A and b are the variables. Observe the powers. It's b to the power of 1, nothing in the sense b to the power of 1. Observe the powers. It is 3, 1, 1, 1, all are, it is a whole number. So definitely it is a polynomial. But observe the variables here. I have a variable a, I have a variable b. How many variables I have in one expression? I have two variables, right? So a will be one variable, b will be another variable. So there will be two variables. Okay, so therefore this is a polynomial. It is not a polynomial in one variable, it is a polynomial in two variables. Okay, so now if I write like this, x square plus 3x plus 2, if I write like this, okay, so it is also a polynomial, right? Polynomial having three terms, right? So here it is, variable is x. We have any other variable apart from x? No, we have only one variable. X is the only variable. Observe that. Whereas here I have two variables, a and b are the two variables. Whereas in this polynomial, I'm having only one variable, that is x is the only variable. Okay, observe the power. It is 1, it is 2. Of course, it is a whole number. Definitely, it is a polynomial, right? This is a polynomial in one variable. So this is a polynomial in one variable. Polynomial in one variable. Okay, so you have some exercise question to solve like this. You need to find out that the given expression or given polynomial is a polynomial in one variable or not, or otherwise it is whether the given expression is a polynomial or not. So that you need to decide that. There is a question like that. Okay, so understood what is polynomial in one variable. If there is only one variable in the expression, then definitely it is a polynomial in one variable. If I am having two variables, then it is polynomials in two variables. Now we are having polynomials in one variable only. Okay, so understood what is polynomial in one variable. Okay, so now let us go to the degree of the polynomial. Let us continue the classwork. Write that degree of the polynomial. Okay, degree of a polynomial. Okay, so what do you mean by degree of a polynomial? Suppose I'm having a polynomial. How to find out the degree of that polynomial? Very easy. Largest power of a variable, largest power or largest exponent. Okay, largest power of the variable is called the degree of the polynomial. Is called the degree of the polynomial. Okay, so largest power of the variable is called the degree of the polynomial. Let me take one example and understand what is degree of the polynomial. Say suppose the same example I'll take, x square plus 3x plus 2. Of course it is a polynomial, right? Polynomial in how many variables? One variable only, right? Because x is the only variable in this expression we have. We don't have any other variable here, right? So here it is nothing in the sense power 1, right? Nothing in the sense, there is nothing in the sense power will be 1 by default. here it is x to the power of 2. So variable is x. So what will be the degree of this? Here it is degree is 1, here it is here it is power is 1, here it is power is 2. So which is highest between 2 and 1? I know we know that it is degree, this is highest, right? So degree will be 2, correct? Degree is equal to 2, that's it. Which is highest power of the variable, then that will be the degree of that polynomial. That's it, very easy to find out the degree of the polynomial. Okay, the polynomial whatever it may be, look at for the variable, find out the variable first and find out the highest power of the variable, write that highest power, that will be the degree. Okay, so this is a degree of the variable, which is very important for your higher classes. Okay, now degree of the variable is done. After learning the degree, types of polynomials based on degree are classification. Okay, classification of polynomials based on degree. Okay, earlier we have classified the algebraic expression based on terms. Okay, one term, two term, three term, based on the terms we have classified. Here we are going to classify the polynomials based on degree. Okay, the first classification will be, if degree is equal to 0, I'll be writing DEG, that is degree. Okay, in short form I'll be writing as a DEG, degree. Okay, write degree only. So if degree is equal to 0, then the polynomial is called, non-zero constant polynomial. It is non-zero constant polynomial. Okay, I had already told you that if there is no expression, if there is only a constant, then that is also a polynomial. Say suppose I don't have these two terms, I have only 2, then that is also a polynomial, right? That I told you on the last class, right? The same concept here also. If the degree is 0, there is a constant, in the sense there is no variable. There is no variable in the sense degree, there is no degree. So degree is 0, correct? So if degree is 0, then the polynomial is called non-zero constant polynomial. So non-zero constant polynomial. Example, if you want to take, you just take any constant. That's it. If I write like this 7, there is no variable here, right? So there is no variable here, in the sense there is no degree. So degree is 0. So it is a constant. It is a constant polynomial. So that means if you are just a real number, then definitely it is a polynomial of course it is a constant polynomial, non-zero constant polynomial. Understood? So it is a non-zero constant polynomial. So let us go for degree 0. Degree 0 is done. If degree is equal to 1, then the polynomial is called linear polynomial. Okay, if degree is 1, then the polynomial is called a linear polynomial. Remember that if degree is 1, then it is linear polynomial. Example, degree should be 1, 3x plus 5. So what is the variable here? Variable is x. What is the power of the variable? Nothing, in the sense it is 1, right? So here it is highest power of the variable is 1, because we don't have x square term here, we have only x term. So that is 3x plus 5. So power will be 1. So which will be the highest power. Okay, so therefore here degree is 1, therefore the polynomial is called as a linear polynomial. So this is a linear polynomial. Okay, now similarly, if the degree increases, if degree is equal to 2, then the polynomial is called quadratic polynomial. Okay, quadratic polynomial. If the degree is equal to 2, then the polynomial is called quadratic polynomial. Example, take any example, take the above example itself, x square plus 3x plus 2. Of course its variable is x here, highest power will be 2, therefore here degree is equal to 2, so therefore this is a quadratic polynomial. Okay. Similarly, if degree is equal to if degree is 3, okay, if degree is equal to 3, then the polynomial is called cubic polynomial. Okay, if degree is equal to 3, then the polynomial is called cubic polynomial. Okay, so then the degree is called as the cubic polynomial. So degree is equal to 0, then non-zero constant polynomial. Degree is 1, then linear polynomial. Degree is 2, quadratic polynomial. Degree 3, in the sense it is a cubic polynomial. Let me take one example for this, for the cubic polynomial. So example will be it should be cubic, x cubic plus 3x square, I have minus also, 5x plus 7. Okay, so observe the variable here, the variable is x here. Okay, here it is nothing, in the sense power is 1, so variable is x. Here it is x to the power of 3, x to the power of 2, x to the power of 1, which is highest power, so this is the highest power, so therefore degree is equal to 3. Clear? So this is about the cubic polynomial. If it is degree is equal to 4, then it is a polynomial in 4th degree or 4th degree polynomial, like that we can call, or otherwise biquadratic polynomial, that will be there in your higher classes. Okay, if degree is equal to 5, then is 5th degree polynomial. Degree is 6, 6th degree polynomial, so it is keep on calling like this. Okay, so classification of polynomials based on degrees. Then what we have learned today, degree of the polynomial. First will be degree of the polynomial we have learned, then how to find out the degree of the polynomial, then classification of polynomial based on degree. Okay, the degree is 0, constant polynomial. Degree 1, linear polynomial. Degree 2, quadratic polynomial. Degree 3, cubic polynomial. Okay, so degree 4, we don't have degree 4, we have up to degree 3. Okay, keep it in our mind, if it is degree 4, then it is a biquadratic polynomial. Then degree 5, then it is a 5th order, I mean 5th degree polynomial. So like that we are going to call. Okay, next class we will discuss some of the exercises. Okay, and we have one more concept to go. I'm sorry, coefficient of the polynomial. Coefficient of a terms. Okay, now I think you have already studied about the coefficient of the terms. Okay, say suppose I'll write one polynomial. Okay, x square minus 3x plus 4. Okay, so this is a polynomial, nothing in the sense it is 1, right? Correct. Now what will be the coefficient of x? What will be the coefficient of x? What is the coefficient of x here? So what is the numerical constant before that variable is called as the numerical coefficient of the variable. Now what is the coefficient of x? Before the x, which is the numerical constant, we have minus 3, right? If it is having minus, then we should take minus also. Coefficient of x is minus 3. Coefficient of x square is plus 1. Okay, this is not a coefficient, this is a constant term. Okay, coefficient of x square is 1. This I had already explained. Coefficient of x square is plus 1. Coefficient of x is minus 3. Okay, This is about the coefficient. Here also, if you find out what is the coefficient of x cubic, nothing in the sense it is 1, right? Coefficient of x cubic is 1. Coefficient of x square is plus 3. Coefficient of x is minus 5. Constant term is 7, like that. So that is about the coefficient. Okay, let us stop here, and the next class we will go for the exercise and we will try to solve the exercise. Okay, thank you.